Right, in this lesson, we shall solve this vector question. Given that the position vector OP is 4 and 13, and the point Q is 16 and 8, find the length of the vector PQ. And we proceed as follows. Right. So we first draw this Cartesian plane here. And we have that. Right, and then now we then have the point P with coordinates 4 and 13. And we have obviously, well, the point P has coordinates 4 and 13 is justified by the fact that the position vector OP is 4 and 13 like so. Okay, moreover, we have that this is the origin O. And we then have that in the end, then we have Q here, which has the coordinates 16 and 8. Right, so the examiner wants us to move from P to Q by saying we must find the magnitude of the vector or PQ there. We can decide, so we shall proceed in the direction of the yellow arrows. So we can move as the yellow arrows dictate, because directions can be changed. Right, so we shall then say we want to move from P to Q. And to do that, we move from P to O, and then move from O to Q, which means that from P to Q, right, what is P to O? We know that OP is 4 and 13, so P to O is the opposite of this, which is minus 4 minus 13 plus. And if I look at this diagram from O to Q, if we move from O to Q, that is exactly 16 and 8. 16 and 8 here. And then now we add these things up, and which means the 16 minus 4, which is 12, and minus 13 plus 8, which is minus 5. Like this. Which means that you have PQ, which is actually 12 and minus 5. The magnitude of the PQ, the vector PQ, is determined by using this particular formula. Okay, so that the magnitude of the vector PQ is the square of x plus the square of y. And these squares yield 144 plus 25, giving us the square root of 169, which is exactly 13 units. Exactly 13 units. And the implication then is therefore that the vector PQ, right, is actually 13 units as required. Okay, it is actually 13 units as required, like so. Right, so the couple of schools of thought as well. Okay, so this obviously ends up as being the answer. Now, there are schools of thought here that can actually be determined. What are the schools of thought? There's an alternative solution to this. So alternatively, if one is having this, if one has, for example, the same Cartesian plane, this is your y and this is your x. We have the position vector OP, which is exactly 4 and 13. Right, so that the point P has the coordinates 4 and 13. we have here the point Q with the coordinates 16 and 8. This is the origin. This is the origin. So in the end then, what we're then getting is as follows. Right, our desire is to move from P to Q. How do we move from P to Q? There are a couple of ways to move from P to Q, and we move from P to Q as follows. What do we do at this point? To move from P to Q, we think as follows, and then say, but how do we do it? We move from P to Q by means of thinking as follows, right? We want to find the vector PQ. So to find a vector PQ, the couple of ways we can do. So we form a new vector by actually considering the fact that you would have here, for instance, 16 minus 4, and then 8 minus 13. Right, so that the vector PQ can be determined as 12 minus 5. And we have PQ, which is the magnitude. So the magnitude is actually 12 squared minus 5 squared, the square root of 169 plus 25, rather of 144. 12 squared is 144. Okay, so you have 144 plus 25, which is 169, and this is 13 units. And therefore, obviously, I mean, this then implies that PQ is actually the same as 13 units. Right, it's the same as 13 units. And this is the answer. All right, is the result. So we have solved the problem step by step and we are done. Right, so thanks everybody for watching and goodbye to you.